All right, students, this is Miss Whitaker here again, and today I want to talk about multiplying fractions. First, I'm going to start out by showing you a model of multiplying fractions, because sometimes when we think of multiplication, we think something is going to get bigger. But I'm going to show you through this model why if I'm multiplying fractions that are less than 1, that I'm going to end up with a smaller fraction. So what I'm going to do first is I'm going to represent 3/4. So if I were to model that with some bars across, let me model 3/4. I'll cut it down in halfway, and then I'll cut those in half. So I've got 4/4 here, and I'm going to shade, let's shade 3 of those to represent 3/4. All right, so this represents 3/4. Let me write that right down here. So 3/4 is shaded, and you can clearly see that. And then the other direction, I'm going to represent the fraction 2/3, and I'm going to do that with my blue. So I'm going to break this up into thirds, and again, I'm going to go the opposite direction. So the other one was up and down. So this one's going to be side to side. So I've broken it up into 3 pieces, and then from there I'm going to shade 2 of those because I'm representing 2/3. So there's 1/3 shaded, and now here's my 2/3 shaded. So that's 2/3 in the blue, and I hope that that's clear for you. Now what happens when I multiply these two fractions, and I'm going to show that right here, is I'm going to look where the two colors overlapped. And you can clearly see where they overlapped, where the green and the blue overlapped were in those squares that I just colored. Now, you can also see after I combined these two fractions that it broke them up into even smaller pieces. Now let's see if we can count those pieces. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12 pieces now. Instead of my 4ths and my 3rds, now I'm into 12ths. And how many were shaded? How many were crossed over? 1, 2, 3, 4, 5, 6. So 6 out of the 12 were shaded with both colors. And that actually turns out to be my answer. When I multiply 3/4 times 2/3, I get 6/12, which I hope that you know that that simplifies to 1/2. And so as you can see, 1/2 is my answer after I've multiplied. But look at my fractions. I multiplied 3/4 and 2/3, and my answer turned out to be smaller than either one of those. Now let's talk about why that is. Well, let's look at our fractions right here. 3/4 times 2/3. Now if I were to think of, let's just do some easy fractions here. Let's think of 1/2 of 1, or 1/2 times 1. What's half of 1? You know that. Half of 1 is 1/2. So don't you think that if I took half of something that was smaller than 1, that it would be smaller than that half? So what we're actually doing when we're multiplying these two fractions that are less than 1 is we're looking for part of a part. So we're looking for something that's even less than part of a whole. We're looking for part of a part. So it is going to be smaller. So hopefully that explains why your answer, when you multiply fractions smaller than 1, is going to be smaller than the fractions you're working with, because you're looking for part of a part. All right. Now the other thing I want you to think about when you're multiplying fractions is the word of. Let's keep something real simple right now. Let's just think of some halves of 10. What's half of 10? 5. What's half of 12? That's 6. What's half of, let's make it a little bit harder, what's half of 5? 2.5. So when we're saying we have half of something, we are actually multiplying. So let's take our example of half of 10 right here, and I'll show you 1/2 times 10. And if I have a whole number, I can put that over 1 so it looks like my other fraction. and I can do that. So that's no big deal. All right, so then I'm going to multiply my numerators. 1 times 10 is 10. And then 2 times 1, multiply the denominators, is 2. And what's 10 divided by 2, or 10 halves? That turns out to be 5, which was my answer that I got just trying to think off in my head. Half of 10 is 5, so I get the same thing. So if you need to remember what you're doing when you're multiplying, think of half of 10 is 5, so I'm going to be multiplying. Just, I want you to relate the word of with multiplying fractions. So let's take some other examples of multiplying fractions besides a half, because usually if we're taking half of something, we can figure it out. Let's stick with the half, but let's do some half of fractions. Let's figure out what half of 7/8 is. All right, so that means multiply. So I'm going to do 1/2 times 7/8. So when I multiply fractions, I'm just going to multiply the tops. 1 times 7 is 7. And then multiply the bottoms. 2 times 8 is 16. And I always want to simplify if I can, if I need to. In this case of 7/16, I cannot simplify. And the way I would simplify is to find the common factor until I can't simplify anymore. But this is already done. We're done with this one. So let's try another one. Let's try half of, let's do half of 3/4. All right, so we're going to multiply the tops. That's going to be 3, and then we're going to multiply the bottoms. That's going to be 8. It's real easy. So what's half of 3/4? 3/8 is half of 3/4. Let's see. Let's look at some other examples real quick. All right, we still want to keep relating the word of with multiplying fractions. Let's do 1/8 times, and now I'm going to use the dot for the multiplying symbol so you can get used to seeing that, times 5/6. All right, remember, I'm going to just multiply the tops. That's 5. Multiply the bottoms. That's 48. And then I think, can I simplify this? No, I can't, so I'm done with that. All right, now I'm going to throw in a little bit something a little different. Let's throw in some mixed numbers. 5 and 5/6 times 1/2. So again, I'm really just looking for half of 5 and 5/6. Now, here I can't work with this unless I change this to an improper fraction. Well, I could, but it would be a little bit more difficult. I'd have to look for half of 5 and half of 5/6. So, but let's just change this to an improper so we can take care of it in just one step. So the way I change it to an improper is I take the 6 and I multiply the 5 to get 30, and then I'm going to add the top 5. So 6 times 5 is 30, plus 5 is 35. Let's erase that and start that one over. Let's say 35, and then the denominator stays the same. I have 35/6, and then I'm going to multiply that to 1/2. All right, now I'm all good. Now I can multiply my tops, 35 on top, and then 6 times 2 is 12 on the bottom. Now this is an improper fraction as opposed to a proper. Improper means the numerator's larger than the denominator. So I'm going to change this to a mixed number, and the way I do that is just look at how many times the 12 will go into 35. That will go in 2 times, because 12 times 2 is 24, and then how much will I have left over? I'll have 11 left over, and my denominator stays the same. So 2 and 11/12 for the answer there. Now I want to show you something a little bit different. I'm going to start with 5 and 1/10, and I'm going to multiply 1 and 2/3. Now let's change these to impropers. Okay, 10 times 5 plus 1 is 51/10. And then I'm going to multiply 3 times 1 plus 2 is 5/3. All right, now I want to show you something, because instead of multiplying 51 times 5 and 10 times 3, there's actually a step that you can take called cross-canceling that keeps you from having to multiply such big numbers. It's actually, just think of it as reducing before you multiply instead of after you multiply. And I'll show you both ways in just a minute so you can see that they are going to end up being the same answer. So what I'm going to do is I'm going to look at my diagonals, and I'm going to see if I can reduce those. I'm going to see if I can find a common factor of the 5 and the 10, and I knew that I could. That's why I wanted to use this example. So look for a common factor with the 5 and the 10, and that's going to be 5. You usually want to find your greatest common factor so you can take care of it in one step as opposed to more than one. So 5 will go into 5 and it goes into 10. So let's reduce those as if it were just like 5 over 10. So 5 divided by 5 is 1, and 10 divided by 5 is 2. So I've changed those numbers. They're going to be equivalent, but I've reduced before I have to multiply. Now I'm going to see if the 3 and the 51 would actually cross-cancel, and I'm pretty sure it will, because 3 goes into 5 one time with 2 left over, and that gives me 21. 3 goes into 21, 7. So it's going to be 3 divided by 3 is 1, and 51 divided by 3 is going to be 17. And then I'm going to multiply. Multiply the tops. 17 times 1 is 17, and 2 times 1 is 2. And then I'm going to change that to a mixed number. How many times will 2 go into 17? It'll go 8 times with 1 left over, and we're still dealing with halves. So we have 8 and 1/2. Remaining, and that's our answer when we multiply 5 and 1/10 times 1 and 2/3. Okay, so I showed you a whole bunch of things here. First of all, we got to change our mixed numbers to impropers, and then also we need to see if we can cross-cancel or cross-reduce before we multiply, and that keeps us from having to multiply such large numbers. So let's try one more example. And then I'm going to let you practice on your own. Okay, last example. Let's do 3/16. And we're going to multiply by 4 2/3. So 4 2/3. Now it's so hard for me to look at this and say, what do I do? Well, we've got to change that mixed number to an improper so they look like just a fraction times a fraction. So 3/16 is fine. Now we're going to multiply 3 times 4 and then add 2. That's going to be 14 over 3. Now let's check our diagonals and see if we can cross-cancel. It just makes it so much easier. All right, so I know right off the bat, I see the 3 and the 3 can be cross-canceled because 3 will go into both of those. So 3 divided by 3 is 1. 3 divided by 3 is 1. Now 14 and 16. Now I know that 2 will go into it, and I think that's what I'm going to have to go with. So do 14 divided by 2 gives you 7. 16 divided by 2 gives you 8. And I think I'm done with it cross-canceling. So now I'm just going to multiply the tops. 1 times 7 is 7, and 8 times 1 is 8, and that gives me my answer of 7/8. So hopefully this makes multiplying step by step and makes it easier for you to understand that. Remember that when we're multiplying fractions that are less than 1, we're doing part of a part, so it's going to be smaller. And then if we have mixed numbers, we need to change those to impropers, so we can just take care of it in one step. And we also learned that if we can cross-cancel or cross-reduce, we want to do that so we don't have to multiply the numerators and multiply the denominators in such big numbers, if we can at all possible. So do some practice, and feel free to email me if you have any questions, and I look forward to discussing this with you in the future. Thanks, guys.